welcome to our channel Euclid Mathematics. I am Swapnil sir and I am today here with one of the previous year question from National Defense Academy and Naval Academy previous year question paper. Already I uploaded plenty of the videos on my channel. If you wanted to see this video, you may check it into my playlist. Now in my today's video, I'm going to explain to you all one of the question. It is from arithmetic progression, completely based on arithmetic progression. Very easy question. It is from question paper 2021. That we can solve this question easily. These questions gives us very easy marks. Now let's get started our question. First of all, we're going to understand the question, then we'll go for the detailed understanding of solution. Here in our question, we have given the value for p. Okay, if p which is equal to under bracket 111 given. Okay, n times one digit is there. Then we want the value for 9p square plus p. Okay, so we have to find out the value for 9p square plus p, and p is defined as one digit up to n times. Okay. But one digit means they are the complete 111 element. There is no comma or no multiplication between them. Okay, that means nth time one digit is there. It is number is quite much bigger there. Okay, then we have given our first option 10 raised to n p, second option 2p into 10 raised to n, third option 10 raised to n into p minus 1, fourth option 10 raised to n into p plus 1. Okay, so we have to figure it out which one of the option is correct between our four options. So let's get started our today's solution. We'll go through the detailed understanding of our solution. So in our question, we have given the value for p. Okay, so what is the value for p? It is possible over here. The value for p, it is here 1, 1, 1 up to 1. Okay, so this is the value for p. It is given. Okay, so this total number of n digit. Okay, this total number of n digits are this. Okay, and then we have to find out the value for 9p square plus p. Okay, so we want the value for 9p square plus p. Okay, so we have to find out the value for 9p square plus p. Okay, now first of all we have to find out the value for p. Okay, we have to find out the relation in our p. What we have relation p with 9p square plus p. Okay, so p, how can we write simplified form of a p? Okay, now let me explain. Okay, so if I consider the element 11, okay, if I consider the element 11, it is a 2 times 11. Okay, so that means n which is equal to 2 over here. Okay, so n which is equal to n here. Okay, n times 1 is there. Okay, so if I consider, let me explain some general case. How can we write general result for this p? Okay, so if I consider 112 times, then we write 1 plus 10. Okay, so 1 plus 10 raised to 1. So I return 11 as 1 plus 10 raised to 1. Okay, when n is a 2, we write 1 plus 10 raised to 1. Okay, that means here the power it is lesser than 1. Okay, now let me go for the next one. So if I take n is equal to 2, power is lesser than 1 here. Okay, so if I consider 1 1 1 3 digit, okay, that means 111. Okay, so how can we write 111? 1 plus 10 to the power 1 plus 10 to the power 2. Okay, now we can see here 10 to the power 200 plus 10 plus 1, that means 111. Okay, so if I consider n which is equal to 3, okay, if I consider n is a 3, okay, number of digits, how many digits are there? 3 digits. Okay, so that's why n is a 3. I'm explaining for our example, general cases for our example. So first case I explained here, second case I explained here. Okay, by using second case I got the value for 10 111 as 1 plus 10 raised to 1 plus 10 square. Okay, now let me explain one more condition. Third condition we'll consider. Okay, so 1 1 1 1. Okay, that means 1111 I consider over here. Okay, that means n which is equal to how much here? N which is equal to 4. Okay, so number of digit here we have 4. So how can we write 1111? Okay, so we can write 1 plus 10 plus, in the form of 10 we have to write. Okay, that we can try to identify their arithmetic progression, geometric progression, or any other progression which exists there or not. Okay, so that's why I'm trying to reduce our term this way. Okay, so 1111 can be written as 1 plus 10 raised to 1 plus 10 raised to 2 plus 10 raised to 3. Okay, so here we can see that. So here if I consider n which is equal to 4, okay, 1 1 1 1, if I consider n is a 4, then we write this way. Okay, if n is a 4, then 1 1 1 1 can be written as 1 plus 10 raised to 1 plus 10 raised to 2 plus 10 raised to 3. Okay, if n is a 4, then we write up to the 10 to the power 3. If n is a 3, then we write up to the 10 to the power 2. n is a 2, then we write 10 to the power 1. Okay, but if n when in the p, if we have n which is equal to n, okay, n which is equal to n in the form of p, if we have n which is equal to n, then we write n the power as a n minus 1. Okay, here 4, then we write 4 minus 1, then here n, then we write n minus 1. Okay, then how can we write p series as 1 plus 10 to the power 1 plus 10 to the power 2 plus 10 to the power 3 plus 10 to the power n minus 1. Okay, here n which is equal to n, then we have to take 1 minus from here, so we'll get the n minus 1. Okay, why? Because n is a 4, then we write 3, n is a 3, then we write 2, n is a 2, then we write 1. Okay, this way n is a n, then we write n minus 1. Okay, so this is the way that we can write our p as a series. Okay, now it is easier that we can find sum of a n term, or we can apply arithmetic geometric progression over here. Okay, now identify first of all what we have here. Is it geometric or arithmetic? Which type of progression? So as we know that geometric progression, it says that when the ratio between two terms which remains same for every digit. Okay, so the ratio between first to second, second to third, third to fourth, it remains same. Okay, that means a common ratio between all the term. Okay, common ratio between all the term, which is r, which is equal to, if I consider r as a common ratio, which is a 10 everywhere same. Okay, 10 is a everywhere same. If I consider a is a first term, a is a 1, common ratio as a 10. Okay, and we can see that we can apply over here geometric progression. Okay, and for finding sum of nth term in our geometric progression, we write, okay, we write a into r raised to n minus 1 upon r minus 1. Okay, okay, geometric progression for a plus ar square plus so on till a r raised to n minus 1. Okay, then we write their geometric progression as a into r raised to n minus 1 upon r minus 1. Okay, r minus 1. So here we can see here r. Okay, r need to be bigger than 1, then and only then it is possible. Okay, if r common difference it is bigger than 1, then we can apply this result. Okay, and if common difference is smaller than 1, so we have to interchange their places. Okay, so here we can see we have common difference bigger than 1, which is a 10. So this result is applicable here. Now substitute the value for sum of a nth term. Okay, first term we have here 1, r raised to n. R raised to n means 10 raised to. Okay, so for the value for n, it remain same. Okay, so it is going to be a 10 raised to n itself minus 1 upon r minus 1, which is a 10 minus 1. Okay, so sum of nth term of our series p, which is equal to 10 raised to n minus 1 upon 9. Okay, so we got the sum of nth term, which is a 10 raised to n minus 1 upon 9. Okay, 10 raised to n minus 1 upon 9. So multiply 9 over here, 9p, which is equal to 10 raised to n minus 1. Okay, so now what we do, take negative over here, so we'll get the value for 10 raised to n. So 9p which plus 1, which is equal to 10 raised to n. Okay, now what we want in our question, 9p square plus p. Okay, so 9p square plus p. So for finding the value for 9p square plus p, what we do, we multiply p to the both side. Okay, if we multiply p to the both side over here, so which is a 9p square plus 1 multiplied by p, which is a p, and 10 raised to n into p. Okay, so what I have done, I applied over here geometric progression. Okay, sum of n term of geometric progression, and then I solve this step further. After solving this, I transfer 9 over here, which is 10 raised to n minus 1. So 9p minus 1, it is here plus 1, 9p plus 1, which is equal to 10 raised to n. Okay, and we want the value for 9p square plus p. Okay, so 9p square plus p means multiply p over here, 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 and here. Okay, so we'll get the 9p square plus p, which is equal to 10 raised to n into p. Okay, now which is given in our option number A. Okay, so option A, which is correct over here, which is a 10 raised to n into p. Okay, now here we can see how easy the question it is. So we have to apply some basic concept from the progression chapter, and we have to visualize what we have given or what type of question we have here. Try to formulate the question, and then you will get the required answer. Okay, so I hope you all have understood my today's lecture. It is completely based on arithmetic progression. Even after if you found anything difficult, let me know in my comment section. I'll come up with some other videos. So thank you everyone. Thank you for my today's lecture.